Hello students, and welcome back to our last lecture of language of chemistry. So I hope you are doing well, and I think you are understanding all these videos. And so far I have made so many videos and for this language of chemistry. So I think you have gone through all of them. Okay, if you haven't gone through them, then please go through them first, because this is the last video and you shouldn't be here if you have not attended the previous videos. Okay, now in this previous videos, yes, this video is an independent video, you can say that, because here we are going to discuss about the combination, displacement, decomposition and double displacement reactions, all of, and redox as well. All of these reactions are actually, they are all the different types of chemical reactions, isn't it? Fine. Now the thing is, yeah, in the previous videos we have discussed about the different types of, like, how this atoms came into the picture, what was the, you know, different types of the timeline, about the timeline, how this atom came into the picture, about the valencies, about the ions. We have discussed about so many things in the previous videos, and they were, all of them are very interesting. You just go through them. Okay, you'd be able to understand each and everything of them. But before starting today's video, I think there was some homework I gave you in the last video, right? So I would just go through them first. Okay, I would just go through them first. Now let me just see. Yeah, so in the last video, so there were some mistakes that I have, changed. Like, well, I was teaching you this thing. Let me just show you a couple of things. Okay, I think you have figured them out. First is, while doing this chemical reactions, while doing this balances, just let me see. Yeah, so these were the homework, and I told you that I'm going to solve the questions in the next video, and definitely I'm going to come to you whether you have got it or not. So yes, in this video, before starting the next part, I'm going to discuss about all these things first. After that, we're going to start with the next chapter. So here you can see, like, these were the questions, and there is a mistake. Okay, so you can see over here, in the last video I have just written Na and H2SO4, so that should be NaOH and H2SO4. Okay, so for that reason, the entire thing, there are so many changes in here, you can see. So this is how you need to balance this chemical equation. So the rest of the things are all just the same, right? There's nothing change in it. Only I have written that there Na, it would be NaOH. Okay, you just go through it, you'll be able to understand each and everything. Okay, now the next part about this is, now this question. Okay, I just gave you as a homework. Fine, this question. So you can see KOH plus H3PO4 giving us K3PO4 plus H2. This was the question, isn't it? Now how to solve this? Now first thing is, you need to write the LHS and the RHS first. Okay, LHS means the reactants. Okay, this means the reactants. I think you remember this were discussed in the last video. These are the reactants, and RHS are the products, PDTs. Okay, the products. Now you can see in the reactant side how many potassiums are there. You can see there is only one potassium, so I have written 1. Okay, just look into the way I'm writing it. So there is only one potassium in the left hand side, so I'm writing 1 over here. Fine. Similarly, for oxygen, how many oxygens are there? You can see for potassium there is 1 oxygen, so for that reason I'm writing 1 here, and plus for phosphoric acid there are 4 hydrogen there, so for that reason 4 with it. So total, there are total 5, right? 5 oxygens, so I am writing 5 there. Got my point? Now after that, you can go to the hydrogen part. How many hydrogens are there in the left side? You can see 3 hydrogen for phosphoric acid over here, and 1 hydrogen for KOH. So total 4 hydrogens. So I'm writing like that. For KOH 1, or phosphoric acid 3, total 4, and phosphorus is just 1. Okay, this was the previous setup of the reactants. Now coming to the product side, so in RHS you can see there are 3 for potassium in here. You can see there are 3 potassium, 1 phosphorus, which is written over here, phosphorus, and how many oxygens are there? 4 plus 1. 4 plus 1, total 5. And how many hydrogens are there? 2. So this is the total arrangement, isn't it? In the left hand side and the right hand side. So first things first, we are going to start with the element having the most number of atoms, isn't it? the most number of atoms. So which one of these is having the most number of atoms? You can start with H3PO4 or K3PO4, any one of that. So I'm just starting with K3PO4 because I can see that in the initial I've written K first, so that is the reason why. Okay, there's no such other reason. So you just start with K3PO4. So it is very simple. For potassium, left hand side there was 1 potassium, and the right hand side there are 3 potassium. So just multiply 3 with it. Fine. That is how you need to balance this potassium first. So just multiply 3 with it. If you just want to multiply 3 with the potassium, you have to put 3 over here, isn't it? You have to put 3 over here. So I'm just rewriting the equation. The new equation would be 3 KOH and all the same things. Fine. Now again, let's just write LHS and RHS, and let's see again what are the things right now we have. Potassium is balanced now. This potassium is balanced. Just let me see. So this one is balanced. Okay, so I am also written it over here, but it's balanced. Fine. Now what about so after that, oxygen. So now again you have to count it because the entire thing has changed, right? So now for oxygen, you can see 3 oxygens are there with KOH, right? 3 oxygens are there with KOH. So for that reason, just wait for a moment. Something's wrong with video. Wait for a second. Let me just see. Check. Yeah. So let me just check this thing first. Yeah, fine. These things happens, right? Now come back here. So the thing is, yeah. So the oxygen, how many oxygens are there? I have 3 oxygen with KOH here and 4 oxygen with here. So 3 plus 4 total 7 oxygen. Got it? Similarly, you just write all these things like that only, in that manner only. Now after that, after dealing with that, we are going to balance. So what are like unbalanced over here? So potassium is balanced. I've written over here. Phosphorus is also balanced, right? So we need to balance hydrogen. Add 3 with H2O. So wherever hydrogen is there, here. So hydrogen has 6 hydrogen, and in the right hand side I have 2 hydrogen. So I need to add 3. I need to multiply this side with 3, isn't it? So just write 3 over here and write 3 in the equation over here. So if you just write 3 in that equation, the thing that is going to come is this equation. So this is the new part. Okay, multiplication of 3. This is the new part. Now after that, again start calculating. The right hand side and the left hand side. You would be able to see that each and everything is balanced now. All the atoms are balanced now, isn't it? So this is the final product. 3 KOH plus H3PO4 is going to give you K3PO4 and 3H2. Fine. This is the final answer. Okay. Now, so that's it, I guess. That's it. And the mistake was there. I've already told you this was NaOH, okay? Not Na, not sodium. So I have again rewritten everything over here. You just go through it in the same manner. You'd be able to understand each and everything from here. Fine. Now let's just go back to our today's lecture plan. Okay. So language of chemistry, 11th lecture, right? There we are going to just discuss about the combination, displacement, decomposition, double displacement, and redox reaction. So this is nothing but different types of reaction. So today we are going to discuss about the types of reactions. This video is the most important because most of the questions comes from this video only, this part only. So you have to give your 100% to this video. Yeah, I keep on asking you for your 100% for each and every videos, but definitely that makes some sense because in this video lectures you can see all the things we are reading right now. All of them are very important, isn't it? You can feel the strength of all these topics. But let me tell you, this is for real. All these 5 topics today we are going to learn. The same things you're going to learn in class 10th as well. So you can understand how many depth does this topics contain. Okay, so this is a very important topic. So give your 100%, give your 100% attention in this video. Okay, and you know that if you don't understand any of it, what you have to do, you just have to write it on our chat forum. Okay, so you just go there and type everything. Definitely one of us would definitely get back to you. Now let's start with this. So the first thing is combination reaction. Okay, now we will start with combination reaction. So it's a very simple reaction. Okay, so it goes on like this. If you have A and if you have another atom B, when they get together during a chemical reaction to form AB, we call it combination reaction. So what do you mean by the word combination first? Combination means combining, right? So this thing, this A and this B are combining together to give AB. That's it. So let's just give you an example. Okay, when magnesium is burnt in air, together they gives you MgO. So you can see this magnesium and oxygen are just combining each other together. Okay, you can also figure it out through another way. When two things are making one, two reactants are giving one product, we can also say that is a combination reaction. Two reactants are giving one product, so definitely they have attached, they have got combined together for that reason only. So this is a combination reaction. Fine, this is how you need to think about it. So let's just tell you how this combination reaction happens. So let's just think about it. We have two balls. Okay, let's see that this is ball A and this is another atom B. Okay, when the combination reaction happens, they just get combined together to give you this. You can see this is a combination reaction. This is being made by these two. These two, when they do combine together, they gives you this. Fine. So this is a new chemical reaction. Okay, this is a new product. Okay, so that's why we call it combination reaction. So you can see from two different things I am getting one, so that is called combination reaction. Got my point? So these type of reaction is a combination reaction. Even if sodium is reacting with chlorine to give you sodium chloride, that is also a combination reaction. Fine, I'm not balancing it. Okay, I think you know how to balance because you have seen the last video, so you know how to balance these equations. Okay, so I don't think like you need my help to balance them. Got it? Now that was all about combination reaction. Now where do we see this combination reaction? We see this type of reaction in the synthesis of anything. Synthesis. So when I say synthesis, what is the first word comes in your mind? What synthesis comes first in your mind? Think about it. You have heard about one synthesis reaction. Isn't it photosynthesis? Right? So photosynthesis is a synthesis reaction. Now, what do you mean by a synthesis reaction? When you are making something. What is photosynthesis? First, tell me. Carbon dioxide, okay, and water. Together, they are, forming glucose. This is photosynthesis reaction. So this is a combination reaction, isn't it? You can see carbon dioxide and water together just getting combined and to give you the glucose. What is this? This is glucose. Fine. This is glucose. Okay. Now, this is called a combination reaction. So a combination reaction is also called a synthesis reaction. Okay. Whenever you see, you will come across the synthesis reaction, that is a combination reaction. Got my point? Clear? Can we move on to the next part? Fine. Whenever you see A plus B is giving you AB, just remember that this is a combination reaction. No, I would show you that video later. Okay, that video is a very interesting video and will that would concise, like after the entire class you'd get the concise idea of everything in this video. Okay, now coming back to the next point, that is decomposition reaction. So decomposition reaction. So where have you heard this? Have you ever heard this word decomposition? I think you have heard it. Decomposition is like, I think you have heard that if something dies, if an animal dies, we call his body is decomposing, right? Right? So its body is breaking up, isn't it? So decomposition reaction is just the opposite. It's just the opposite of combination reaction. Let's see. So if AB gives you A plus B, this is just entirely the opposite reaction only. We call it decomposition reaction. Okay. For a moment. When AB gives you A plus B, that is called a decomposition reaction. So let me show you an example. If you have calcium carbonate, if you just heat that thing, you'd get calcium oxide and carbon dioxide. This is a decomposition reaction. You might be thinking this is a very difficult example I have taken. Okay, let me tell you. Whenever you see this carbonate, okay, CO3 group, that breaks up to give you carbon dioxide. You know about it. Let me tell you where you have heard it. Do you remember baking powder or baking soda, anything, baking soda? Tell me, why do we use this? Tell me, pause this video and think about it. Why do we use this baking soda? To make cakes, right? To make cakes, biscuits, the things that we want to be fluffy. We use baking soda there, isn't it? Why do we use baking soda? Look, the formula of baking soda is NaHCO3. Now you can see there is a word CO3 over here. So it is going to give you CO2. So every time you see this CO3 groups, and if you are just heating it, there is a very high possibility that it is going to give you CO2. Okay. Now that CO2 is the only reason why your cake is getting fluffier, because that CO2 is, the gas which is making that thing fluffy, making that thing sponge-like, okay, foam-like. Clear? Got my point? So this was called the decomposition reaction. So decomposition reaction is just the opposite of combination reaction. So let me show you the thing again. So if this is the product, if this just breaks down like that, if this is breaks up like this, so that is called a decomposition reaction. This is combination and this is decomposition. Got my point? So formation of this bond is called combination. Breaking of this bond is called decomposition. So I think you are well aware with the word bond. Bond is not James Bond. Bond is this thing. So every, like, I think you can see it. Isn't it? Yeah, this guy over here. So the thing is about the bonds. Bonds are something like hands. Okay, like you have heard about valencies in the last class. So bonds are just like the hands. Okay, you can see they're just holding each other's hands to make it, to be together. That is the thing. Okay, now today my video is, is a little bit making some problems. Okay, just ignore that. Fine. Now let's get back to our points. Okay, now that is called, you're understanding it, right? You're understanding it. Fine. Fine. So that is called a decomposition reaction. So decomposition reaction, when does it occur? In every type, when we heat things, it just breaks up into, its constituent particles. That is a decomposition reaction. Apart from that, like when we, have you heard about this? When we pass electricity from H2O, in water, if I pass some electricity through it, what would happen? water would break up into H plus and OH minus. So that is also a decomposition reaction. So breaking is decomposition. Whenever the bond is getting broken into two pieces, that is a decomposition reaction. Clear? Okay. So that was all about it. I think you got this point as well. Fine. Can we move on? Okay. Yeah. So moving on to the next point. That is called a displacement reaction. You know, when you'd be in class 10, you'd be reading that how many types of decomposition reactions are there. There can be thermal decomposition, there can be electrolytic decomposition, there can be, photo decomposition. Okay, so photo decomposition is something like if you just keep it inside the, if you just keep it in sun, it would get broken into pieces. Like, let me show you, like AgBr, okay, silver bromide. If you just keep it under the sun, so I'm just drawing sun over here. If you just keep it under the sun, it would get broken into Ag and Br2. You don't need to remember this, but it's up to you. Okay, this is an additional knowledge for you. So we call it photo decomposition. This decomposition can also occur if there is some sound around you. Okay, even decomposition by sound is also there. Okay, we will learn about it in class 10. Displacement reaction. Now, what does it suggest? When you see this word displacement reaction, tell me, displacement, replacement, all the same, right? All of them are just the same. So when you are replacing something, what do you mean by the word replace? So when you go to a supermarket, okay, like think about it, you have bought a new t-shirt, okay, and for your dad, but when you are just giving it to him, he just tried it, but it's not getting fitted like that. So with his shape and all this thing, he's still, let's just think about, he wears XL and you have taken double XL. So definitely you are just going to change it, just going to replace it, right? So when we just replace something, that is called replacement. And what do you mean by the word displacement? When you are replacing something from its position, we call it displacement. So it's like if you have A, and that is getting reacted with XY. A is getting reacted with XY, okay, and it is giving you AY plus X. Think about it. A is just replacing the position of X, and Y is there. So together they are making the complex now, AY. Okay, and X is getting displaced. Got my point? This is something like how does it happen, right? You might be thinking, how does it happen? So just tell me, if I just think that you are new to a place, okay, so let's just think that this is a company and you are new over here. You're going there for the first time, okay? Now this is you, and this is your senior, and this guy over here is your boss. Fine. And this is your junior as well. So A, B, C, D, and E. These are their names. Okay. Now think about it. If you are the one to be displaced or to be thrown out of the company, then who can do it? Would it be done by A, or would it be done by C, D, and E? Definitely your boss and your seniors can throw you out of the company, not your juniors, right? So similarly, more reactive substances, would displace, isn't it? Tell me, the less reactive one. Fine. The less reactive one. So more reactive, the one which is the more reactive, it would displace the less reactive one. So if I just tell you, like, if there is zinc and if there is CuSO4, if there is zinc and if there is CuSO4. So zinc is more reactive. Zinc is more reactive than whom? Than copper. Then what would happen? So it would displace this copper and you would get ZnSO4 plus Cu. Fine. So this is the product. Now, if someone asks you, what would happen? What would happen if I place an iron nail? Look into it, okay? What would happen if I place an iron nail into a copper sulfate solution? So let me tell you, a copper sulfate solution is blue in color. Okay. So what would happen if I just place an iron nail into a copper sulfate solution? What would happen? Iron is more reactive than copper. Okay. So as a result, what would happen? It would displace it. And you would get FeSO4 plus Cu. Got my point? Now, the speciality about it is FeSO4 is green in color. FeSO4 is green in color. So what would happen? So if I just try to draw the picture that would happen here, let's see whether we can draw it or not. So if this is a test tube, and previously if there is copper sulfate solution in it, copper sulfate is blue in color, okay? Okay, this is a blue colored copper sulfate solution in it. Placing an iron nail. Wait for a moment. Yeah. So I'm placing an iron nail over here. So what would happen? The iron nail contains iron, and this is copper sulfate. What would happen? It would just replace this copper, right? To give you FeSO4. So then what would happen? FeSO4 is green in color. So now that the thing that would happen is the entire solution would turn green as time goes on. Okay, because FeSO4 is green in color. So the entire solution would get changed into a green color solution. Got my point? This is the thing that is going to happen. Okay, so this is like FeSO4 because FeSO4 is green in color. Okay, so it would become green. Okay, as the blue is the more predominant one, so for that reason what is happening, green is going to the background. Okay, and blue is coming up. So you don't forget about it. So entire thing would be green. I think you got it. Okay, again it is going to just go in the background. Just focus on this thing. Okay, so it's going to go on the background again. Just don't worry about that. So the thing is, that is the entire thing is going to get converted into green color. So this is called a displacement reaction. So I think you have seen football matches. What happens in football matches? A player comes and displaces another player from the field. There are already 11 players playing, right? So if a player comes and displaces any one of them, then we call it displacement reaction, isn't it? And we often see these type of things in football matches, right? Substitutions as well, right? We call it substitution reaction as well. Getting my point? So this is the thing about, so maybe you might be asking me a question right now. So how do you know who is more reactive and who is less reactive? For that, you need to, go through metal activity series. So for the metals only, okay? Metal activity series. So this is a series that gives you the idea about the metals. Those are, and the like, who is more reactive and who is less reactive. Like it goes on like this. Okay. This would be magnesium over here. Okay, so this goes on like that only. Iron should be here. There should be nickel. Okay, so this is an activity series. Okay, more you go downwards, the reactivity decreases. So from there, I think you can understand. So copper comes after hydrogen. After there is hydrogen over here. After that comes copper. So you can understand if zinc and Fe, you are reacting these two things with copper sulfate solution. So they are going to replace that, isn't it? So because they are more reactive. So this thing is the most reactive. Fine. Just wait for a moment. Yeah. Most reactive. Got my point? So this is the thing about the reactivity series. I think you got it now. So let me see how many of the things we have completed. Combination reaction is done. Displacement reaction is done. Decomposition reaction is done. Now we are going to focus on double displacement reaction. I think we have got everything so far, isn't it? Now, this is also simple, isn't it? This chapter. So this is the last video, okay, and we have only a few things left to discuss. Okay, so I think I got you all, I got your ears, right? Just focus on here. This is double displacement reaction. We call it double displacement reaction. So, okay, one more thing. I just forgot to show you how the displacement reaction looks in this way. So, yeah, let's just take that. So let's just see we have this. Okay, let's just say we have this. Okay, now another atom comes and hits this and replaces this, hits this and force it to go out of the system so that it can make the bond with this thing. Okay, so if it hits this and force it to go out of the system, what would happen is I would get these two as a product. Okay, I would get these two as a product. You can see that this was actually here, isn't it? And the green ball has came and replaced it. So this would now be alone, like the green ball was previously. It would be alone and the green ball would be reacting with it, isn't it? So the first thing was just like this. When this came and hit this thing, it get converted into this. Got my point? So that is a displacement reaction. So now we are going to discuss about double displacement reaction. Now tell me what that would be. Definitely you would be having this displacement reaction twice. Okay, if you have AB plus CD, what is the thing you are going to get from here? So A would replace C, A would replace C to give you AD, and C would replace A to give you CB. Got my point? So this is like that. You have these two together. You have these two together. Just wait for a moment. Let me see. My video is still not working properly. Okay. Yeah. Okay. We have these two things. Okay. Now they are reacting with each other. Just look into the colors. Look into the colors. They are reacting with each other. And after the reaction is done, I am getting. After the reaction is done, I am getting these two. Have you seen the change? This green was actually here and this black was actually here. So now they have changed their positions. So this is double displacement. 2 times. The displacement is occurring for twice. So the same thing is happening over here. Let's just give you some example. So if I have, let's say if I have NaCl who is reacting with H2SO4, and if I get Na2SO4 plus HCl as a product, then that is a double displacement reaction, DD reaction. Fine. Or if I just write like this, NaCl plus KOH, and from here I'm getting as a result KCl and NaOH. That is called double displacement. So you can see that both of them are changing their positions, isn't it? So these type of reactions are called double displacement reactions. So you can see sodium was preliminary over here. Now, along with Cl, now sodium is there with OH. Okay, so it is just going there and replacing K, and K is taking the position of Na. So this is called a double displacement reaction as well. So that was all about it, like double displacement reaction, and we are only left with one of them. I think you got it as well, right? You got it? You got it? Very simple. This was the double displacement reaction. Now, the last part. Okay, the last reaction. Look into it. This is the last reaction. That is redox reaction. This is redox reaction. This is also very simple, but there are so many concepts. Okay, wait for a moment. Yeah. So what is a redox reaction? When reduction and oxidation, both of them are occurring in a reaction, we call it a redox reaction. Fine. We call it a redox reaction. So red from reduction and ox from oxidation, together they gives you redox. Just remember one thing, red and ox always occur together. So you will not be able to see any of the reactions where only reduction is occurring, but there is no such oxidation. You'll not be able to see these type of reactions ever in your life. Fine. Now, what are the redox reactions? So to understand the redox reaction, I think we need to understand about the oxidation and reduction first. So what is oxidation? First, oxidation is nothing but plus addition. Okay, so when there is an addition of oxygen, we call it oxidation reaction. When there is a addition of oxygen, we call it oxidation reaction. Let me show you how. Okay, so let's just think about a reaction like this reaction we have already discussed, right? Mg plus oxygen. This is giving you MgO. So now Mg to MgO, what is this? Mg was previously, Mg had no oxygen with it, but now MgO has an oxygen with it. This reaction is called oxidation. So whenever there is an addition of oxygen, we call it oxidation reaction. Fine. Now, what is happening to this O2? Initially, it was having 2 oxygen atoms. Now it has only 1 oxygen atom. So there is a subtraction of oxygen, isn't it? First, it was 2 oxygen atoms. Now it is having only 1 oxygen atom. So this thing is exactly the opposite to oxidation. So whenever there is a reaction opposite to oxidation, we call it reduction. Okay, so that is called oxidation and reduction. If I give you another example of that, okay, think about it. Let me think about it. Na2O, okay, Na2O plus, okay, just draw it like that, write it like that. Sodium plus, let's just take, this is an arbitrary reaction, okay? This is an arbitrary reaction. MgO gives you Na2O plus Mg. Okay, that's the chemical reaction we have. Now, sodium is becoming, it is just reacting with the oxygen, it is becoming an oxide. So this is called an oxide. Now, as there is an addition of oxygen for this, so this is an oxidation. Fine. And what happened to Mg to MgO, MgO to Mg over here? There's a subtraction of oxygen, okay? We call it reduction. Fine. So oxidation and reduction are just the opposite things. Fine. Okay. Now the next thing is like this was all about it. So we can just discuss about the reactions and the videos I was talking about. Okay, let's see what is there in the video. Fine. Okay. Now let's see what is there in the video. They're saying that chemical reaction helps us to understand the natural reactions. So how this pizza is getting baked, how the fireworks are getting made, how how the cancer cells are getting decomposed. So you can see the combination reaction when two atoms are combining, A and B are combining together, we call it AB. So you can see the generalized formula, A plus B gives you AB. This is the combination reaction. Got it? This is how this reaction occurs. So you can see, can you see the entire reaction, how it occurs? At first, the purple colored gas is going up. That is the iodine gas only. So at first, this entire thing, you can see the entire thing is, it has already catch fire. Okay. And the first, the iodine gas were just going out. After that, they reacted in this high temperature and under this flame to give you that AI. So you can see this is the structure of the product aluminum iodide. Okay. So aluminum and iodine, there are two reactants. Now there is only one product. So 2 to 1, the formation is combination reaction. Whenever you got two things converting into one, that is combination reaction. And exactly the opposite is the decomposition reaction. So there it occurs in all types of synthesis process, like the photosynthesis and other types of like the formation of glucose. You can see glucose and oxygen, right? This is the product of synthesis process. Now coming to decomposition reaction. So have you just seen like how this decomposition reaction came into the picture? Before coming, they were showing some skulls and things, right? Look into it. Yeah, there. Have you seen it? Decomposition reaction, they are showing some skulls. As I told you, like decomposition means it's a breaking, right? And you have also already we use this word when we are just discussing about decaying body. A body is decaying. That is called also decomposing, isn't it? Now the opposite, you can see like a synthesis reaction, they are just getting attached, but here they are just getting departed. You can see that how you can show it. So now you can see hydrogen peroxide. This is a thermal decomposition. Let me show you how it happens. Yeah, so you can see if you just keep it there, okay, sorry, that's for the photo decomposition. Okay, so if you just put this H2O2 there under the sunlight, it would just, you can see it would just form the bubbles and it would just get decomposed. But the thing is, if you just want to make it faster, you just have to add some catalyst with that. You can see how the oxygen gas and water is coming. That's a very good thing they're saying. When a car accident occurs, you can see that airbag comes out within few seconds. That is a product of a decomposition reaction. Okay. So the thing is, inside that airbag, there is something called sodium azide. You don't need to know about it. Sodium azide, NaN3 azide. Okay, NaN3. Sodium azide is there inside the bags. Okay, when it just hits something, the sodium azide decomposes into sodium and nitrogen gas, and that is the thing that that is inflating the entire bag. Okay, so from there, it is only saving us from hitting with something, hitting our head with something. That is what these airbags are. Okay, now they are trying to discuss about a combustion reaction. So I think you know about a combustion reaction. When something reacts with oxygen and gives you immense amount of heat and light, that is called an combustion reaction. Still, we will just discuss about it. So you can see when combustion reaction occurs, they just gets attached with oxygen, and apart from that, heat and light. Right? So now you can see this is, they are trying to make this reaction with like the methane gas and methane gas. I think you've heard about methane gas, and like that is there in CNG, compressed natural gas, methane gas and oxygen. Let's see what would happen. So methane and heat gives you carbon dioxide and water. So that is the thing they are saying, just like without this combustion, you would not be make barbecues. Okay, that gives you so much amount of heat, isn't it? For that reason only, it is used in cooking. Okay, because in cooking we need a huge amount of heat. So now this is single displacement. They're saying, they're calling it like single displacement, not only displacement. We called it only displacement reaction. All the same, right? When one is replacing another, that is called a displacement reaction. The same thing we have discussed about it, like A plus BC gives you AC plus B. That is a displacement reaction. So you can see. So now you tell me what would be the product. Copper wire in the silver nitrate solution, Cu plus AgNO3. What is going to be the product? Tell me, displacement reaction. Copper is going to displace silver and you are going to get copper nitrate and silver. So you can see how it's happening. That is the thing, isn't it? Now you can see that these silver crystals are beginning to accumulate on this wire. You can see that there are silver crystals throughout the wire, isn't it? So they're saying that this is a thermite reaction. You would learn about it later. So these reaction, this type of displacement reaction helps us to even to make the tracks. When there is a crack on the track, on the railway tracks, then it would help to fill it. Okay, that is a double displacement reaction now. So AB and CD, they are just replacing each other. Isn't it good? This is the generalized formula, right? AB plus CD, AD plus CB. Got it? Very simple, isn't it? Now look into it. When potassium iodide is added to lead nitrate. So when the potassium iodide and lead nitrate both are colorless, okay, when they add them up, you can see the yellow color PPT is forming. You can see, isn't it beautiful? So this is lead iodide, the yellow one. Okay, when potassium iodide and lead nitrate are reacted together, you can see lead iodide is showing the color over here. Okay, so I think you can understand up to this everything, right? So right now they're just trying to give you some example how these antacids are also showing the double displacement reaction and everything about it, right? I think you got it. Now I would just share the PPTs with you so that you can understand it. Fine, I think you can see it. I think you can see it. Now, let me just check it again. Fine. Okay, let's just go through it. So first is topics covered. Okay, forget about it. The combination reaction, you can see A plus B is giving you AB. Okay, that is a combination reaction. Decomposition reaction is AB is breaking into A plus B, exactly the opposite. Neutralization reaction is when when there is an acid and there is a base. If you just add this acid and base together, you would get a salt. Okay, that is called a neutralization reaction. Okay, so the acidic character and basic character both are and neutralization reaction both are being neutralized with each other. Combination reaction, you can see this is the product and you can see how this GIF is helping you to understand about the combination reaction, isn't it? It's a very important GIF. Now, displacement reaction, we have already talked about it. A plus BC gives you AC plus B. This is also a displacement reaction. Decomposition reaction, when AB breaks into A plus B, that is a decomposition reaction. You can see like this was a thing and it is breaking into things. Okay, so for that reason only, okay, that is called decomposition reaction. Now coming to the double displacement reaction, you can see here, okay, when there are some mistakes over here. Okay, let me just check it. X, okay, we should write it like A B plus XZ. Tell me what would be the product. AZ plus YB. Okay, just give me a moment. So this is the double displacement reaction. You can see they are both of them are replacing each other, right? This is the double displacement reaction. So you can see in double displacement reaction, okay, they haven't given you any of it. So I think you have got it right. When these two were displacing each other, I think you got that point, isn't it? Okay. What would I get from double displacement reaction? I would get this. I'd get this and this. Isn't it? This is double displacement reaction. Fine. The redox reaction. So whenever there is an addition of oxygen, we call it oxidation. When there is the opposite thing, replacement of oxygen, we call it reduction. Fine. Now let's come back to the FAQ questions. So sorry, frequently asked questions, FAQs. How do you understand, identify this? There is a chemical reaction. Look, if there is a chemical reaction, everything is going to get changed. There is no such physical property which is going to match with the chemical product. Okay, let me show you. A chemical reaction is typically followed by physical signs that are readily detected, such as heat, light emission, and precipitated formation, gas evolution, or change in appearance, change in color. So all these things may change in during a chemical reaction. Heat may come up. Okay, all these things are happening in a chemical reaction. How to identify a physical and the chemical change? So chemical change is typically followed by physical signs, and there. So the thing is, like, physical change and the chemical change are just the same thing. Okay, not just the opposite thing. Okay, when there's a chemical change, that is due to the chemical reactions. Okay, so chemical change may change everything. You can change the color, it can change the texture, it can change the entire thing in chemical changes. Okay, think about it. Just let me show you something about chemical changes. So let's just consider, that you have hydrogen in gaseous state, you have oxygen in gaseous state as well, to give you H2. Fine. Now hydrogen over here, this is inflammable. This is inflammable. Fine. Oxygen over here is supporter of combustion, isn't it? But together they're giving you a product. Together they're giving you a product, H2O, which is, so this color would not be seen. They gives us a product H2O, which is helped in extinguishes the fire, which extinguishes the fire. So I think you can understand, like, this product has to do nothing with the reactant, has to not do nothing with the reactant. It extinguishes the fire. Okay. But H2 is supporter of combustion, oxygen is supporter of combustion. Together they're making something new. There is no such repetition of the properties of the constituent particles. Okay, so that's it, I guess. That's it. You have understood everything, I guess. Okay, this was the last video. Okay, and I'm going to miss you. And if you don't want to miss me, then you just have to keep on watching this video. Okay, I'll definitely make some other videos as well, but you have to keep on learning these things. Okay, so the thing is, you just keep on practicing it. You have so many forums from where you can find these questions as well. Okay, so just keep on practicing this, and I hope to see you soon. Okay, fine. Bye everyone, and definitely we'll meet in the next video. Okay, fine. Bye everyone.